Okay, so now we're ready to talk about the types of reactions that you guys have to be aware of in this class. We're gonna start by talking about synthesis, and then we'll finish up the video by talking about decomposition. Alright, so synthesis, also known as combination, is the reaction in which you start with multiple reactants, but you end up making only one product. That's the characteristic of a synthesis reaction. Now this once again could be elements making one molecule, or this could be two molecules making an even bigger molecule. But the idea is that you have to start with multiple reactants and end up with only one product. That is what characterizes a synthesis reaction. A specific example of this is the rusting of iron with dioxygen gas. Over time, you probably do know that iron does react with dioxygen, forming rust. And specifically what rust is, not entirely, but to a large extent, is iron 3 oxide, which is depicted here as the solid product. It's usually an orange looking product. You've probably seen it if you've ever been to a junk yard, with old cars. But the idea right here is that you are reacting two different species and forming one overall product, no more than just one product. All right, now, aside from identifying the reaction as a synthesis, it is important that we do balance the equations. This is going to be the central theme of this lecture, but there's going to be layers associated with it. But balancing is by and far the most important theme of this lecture. So looking at our atoms, you see that we have one iron atom on the left side, but we do have two on the right side. So we're going to have to balance this. Now, before we get into that, though, I want to point out something. We have O2 on the left side, and we have three oxygens on the right side. Whenever you see this idea that you have an element with an even number associated with it, and on the other side of the equation, you have an odd number, or vice versa, what you have to do is cross multiply the molecules where that element is present, specifically by the numbers already present in the molecule. So if you have two oxygens on the left side of the equation, you multiply the molecule that has oxygen on the right side by 2, and vice versa. If the molecule on the right side has three oxygens to begin with, you multiply the entire molecule that contains oxygen by 3. And by doing so, you basically ensure that the number of oxygens in this even odd situation are balanced. All right, now let's take a look at iron. We have added a 2 in front of Fe2O3, so we need to account for the number of irons total. We have 2 irons within the molecule, but we have 2 molecules that contain iron. So altogether we have 4 irons. And another way to put this is that the coefficient outside of the molecule and the subscript of the element have to be multiplied together. So we have 4 irons, and that means that we need to add 4 irons on the left side of the equation. This ensures that the equation is balanced. All right, so now we have balanced our first synthesis reaction. Now, decomposition in a way is very similar to a synthesis reaction, except that we are doing the exact opposite. We start with only one reactant, but we end up making multiple products, at least 2 of them, but there has to be 2 or more in general for this to be a decomposition reaction. And one example that I can give you, one example that you probably have done in Chem 10 or Chem 151, is the decomposition of potassium chlorate into potassium chloride. Specifically, heating up potassium chlorate liberates dioxygen, but notice the format of the equation. There's only one reactant present on the left side of the equation, whereas we have 2 products being formed on the right side of the equation. So this has the correct premise for it to be classified as a decomposition reaction. Okay, now, once again, if you look at oxygen, you can see that you have 3 oxygens on the left side, 2 oxygens on the right side. So we have this even odd situation taking place once more. So we will cross multiply each one of the molecules containing the oxygen by the opposite number. So this 3 means that we multiply O2 by 3, and the 2 of O2 means that we multiply KClO3 by 2. That will ensure that the oxygens are balanced. Now that of course changes the amount of potassium and the amount of chloride that we have, the amount of chlorine that we have on the left side of the equation. Now we have 2 of those 2 elements, so we need to ensure that we still have 2 potassiums and chlorines on the right side of the equation. So with that being said, we have now balanced the decomposition reaction.